بسم الله الرحمن الرحيم. اليوم راح نحكي عن مقالتنا بعنوان Performance Analysis of the Hot Storage Tank. Hot storage tanks has many important applications in electrical heaters, solar thermal storage, and even in solar electric energy production. I'll skip the literature right here. We have many previous studies about the hot storage tanks and its importance, the effect of mixing within the hot storage tanks. This is the mixing number. Here is an application combining the hot storage tank with the solar collector. And this is the stratified flow of hot storage tank, the hot water and cold water in the storage tank. I'll take it short. In this paper, we are analyzing the mixing within the hot storage tank between the cold water and the hot water. It's very important to separate the two layers to have a maximum hot water to the consumer. As you see, the temperature distribution is shown in the figure, and right here is different timing for filling the hot storage tank. Here, the supply inlet of the cold water within the hot storage tank is shown, different supply inlets. In our study, this is the application in energy or electrical energy generation. In our study, we analyzed the side flow effect and bottom flow effect with and without cover, using different quantifying parameters. I'll talk about it later. This is the apparatus that we used in our experiment, data acquisition system, hot storage tank with a certain dimension, flow meters, pumps, and certain connections. Right here we have the dimensions and parameters variated within our experiment. Here we see the temperature distribution within the hot storage tank, and we can notice the fluctuation of temperature inside the tank. The most important point right here is to have the maximum amount of hot water to the consumer at any flow rate. Even as you know all, if we used low flow rates, we can get high quantity of hot water, but unfortunately, in many cases, we need to have high flow rates. It's not only used for showering. This is the temperature distribution with cover, side supply mode at 8 liters per minute. The case is studied right here for side supply, low flow rate and high flow rate, covered and uncovered, with bottom flow supply with different flow rates. We analyzed the problem with dimensionless time, dimensionless temperature. We studied this problem as a function of thermocline thickness, mixing number, discharge efficiency, and exergy efficiency. Right here, this figure shows the thermocline thickness. Simple note, you can observe that the highest thermocline thickness is given for 10 liters per minute, the uncovered mode supply. The rest even we have certain differences which we can say that this part is better than this part, but you can observe that the three other lines, which is 8 liter per minute, 3 liter per minute, and 3.5 liter per minute, covered and uncovered, they have the same thermocline thickness approximately. Right here, the mixing number is shown, and I'd like to note the mixing number within the tank for the covered and uncovered flow rate. Both mixing numbers are almost the same, 3 and 3.5. We can observe right here for the covered flow rate, even low flow and high flow rate, almost the mixing number is the same, but there is a notable difference between the uncovered and low flow rate You can see the difference between the mixing numbers, and it shows that the mixing number is higher for 10 liters per minute, the uncovered mode. Here is the discharge efficiency, how much energy achieved out of the tank. Again, it's noted that the maximum discharge efficiency is achieved for the low flow rates, and the minimum one is given again for 10 liters per minute for the uncovered mode. Exerge efficiency gives the same conclusion. For the bottom flow, bottom supply, the bottom supply again, here is the uncovered and covered modes. We note that 9 liters uncovered, you can notice how much high is the thermocline thickness, which indicates the high mixing within the tank. That's means the cold water and hot water is gonna mix and will not achieve enough hot water out of the tank. This is the mixing number. Here is the study of the mixing number. And again, we note that for the uncovered mode, after you leave the low flow rates, 6, 8, and 9 liters per minute, all of them high mixing number. Don't worry. For the covered mode, 3 and 9 liters per minute is low mixing number, and the high mixing number is given for the 9 liters per minute uncovered mode. All of these parameters, including the thermocline thickness, mixing number, and even you can notice right now the discharge efficiency, it gives the same results as a quantifying parameters of the hot storage tank. All these parameters that we are using in quantifying the hot storage tank efficiency. Discharge efficiency, the best is for the low flow rate. And as advice, you can get always trying to use low flow rates or using special designed hot storage tanks which has certain distributing inlet for the cold water. The discharge efficiency has a maximum discharge efficiency for the low one, but please notice the discharge efficiency for the high flow rates. For the high flow rates, it's approximately 76%. Even at high flow rates, we are achieving a discharge efficiency of 76%. Whereas for the this is the exergy. We can go back. For the discharge efficiency, the covered, this is the exergy, and this is the discharge efficiency. You can notice the discharge efficiency right here, which reaches almost 98%. discharge efficiency right here is almost 62%, and the discharge efficiency in the covered mode, even for the high, it's almost 76%. This is the result. Again, it notice the low flow rate, the advantage of using low flow rate or using covered supply inlet. Thank you very much.